Okay, so Einstein's compass moment a little bit with Scratch. So Scratch is very simple, and if you're worried because there's going to be a lot of complicated stuff thrown around in your beginning programmer, you should rest and relax because Scratch it has drag and drop things. So here's looks, you can say things, you can change you can change the color, you can change your costume. There's sound, you can make him you can play a sound, meow. Different stuff. Most of our stuff will have these control loops for if then else. So you would do if, um, make a variable my name, if my name, oh, it shouldn't be less than, say equal, that makes sense. If my name equals Fred, now my name currently equals 0 because I didn't set it to that. But there you go, I have an if then else. My name did not equal Fred, therefore I meowed. Okay, so that's kind of how Scratch works, and that seems way too simple for some of you guys. Let me show for both sets of people, the people who think it's too simple and the people who think, hey, I like this Scratch stuff. Let's just talk about exploring Scratch. And so you can explore, and I'll give you different topics you can look into. Animation, games, music, stories, tutorials. Tutorials are awesome. They might be a little bit advanced if you're just starting out. All sorts of stuff, okay? But let's go up here and look for artificial, I'm a terrible speller. It's not because I don't care about spelling, I'm just bad at it. Okay, and so here we have different artificial life programs. Some of them are complex and graduate school level, some of them are not. That was artificial life. We could look at neural networks, which is a component of computer learning and also a simulation of the human brain. So these are things that I first encountered in my research position. So these are, oh, this is one. Amazing. I am amazed because I've programmed these in similar things but in different computer languages. But to program a whole neural network is extremely hard. So there is no limit with Scratch to what you can accomplish. Some things will be more convenient to do. You can look inside and you can see all the code. If you want a really great thing to do is to find something and then hit remix. That credits the person instantly gets a nice little notice that says, hey, somebody remixed your stuff, you're really cool, and that helps their stats, and also gives you a copy of the program that you can do whatever you want to. Won't break the original. You should try to break this one, try to change its behavior, learn different things about it. So that's a great way to learn. But Scratch is, I know that Scratch will be able to handle all of the algorithmic challenges you will put to it this semester. And I can say that with certainty because of this guy. This is Alan Turing, who was probably the most famous computer scientist that ever lived, who was a British subject during World War II and helped with the ENIAC program and the code breaking that broke the Nazi codes using computers. He also has many things named after him, and many of them are very different. One of them is a definition of a Turing complete language. He reduced to its mathematical underpinnings what computer languages actually do. And he demonstrated that any computer language which is Turing complete can solve the problem that is solved in another Turing complete language. So if I solve a problem in C++, which is a Turing complete language, If I solve that problem using the Turing-complete aspects of the C++ language, it is a mathematical certainty that it is possible for you to solve it in Scratch. Doesn't matter how many lines of code I had to put in, whatever, it is mathematically possible for you to solve it in Scratch. We'll see that some languages lend themselves better to different things, but Scratch has sufficient power under the hood for you to program in it. I can also tell you that one of my students I worked with here locally at the Science Museum applied to the Institute for Human and Machine Cognition. He had only ever done Scratch, but he was applying to a lab that was run by MIT grads who know MIT computer science grads who know about the theoretical underpinnings of Scratch, and he was accepted with Scratch as his only computer language on his resume. Within 2 weeks, he was leading the coding development team. So Scratch is sufficient to do all of the work in this class. You are not required to use Scratch, but Scratch is sufficient. You might have been expecting to learn a computer language in this class, and we're just not going to be able to do that. Other than Scratch. I will teach you Scratch and help you in any way possible. But if you looked at a standard, I think this is Python. If you look at standard computer coding, text-based computer code languages, Python, Ruby is a good one. C#, if you're into game design, is really an important one. Different computer coding things that are text-based, you're going to have to spend a lot of your time on syntax. Syntax means getting things down exactly precisely correct. So it's the order in which you put the words, making sure the words are exactly the right words, all that kind of stuff. If they're not exactly precisely correct, the computer will not operate it. You'll get an error, you'll spend all your time debugging. And so when you just wanted to have your computer program say something, you might spend a lot of time trying to figure out how to get the printing function to actually work properly in the different computer programming language that you're working in. That is called coding, is dealing with coding syntax, and it is important to learn coding syntax. I encourage you to learn a language other than Scratch. But people get confused and think that coding syntax is all that there is to learn in computer science. And it's a big, dangerous idea, and it actually prevents people from learning the real ideas. So to show that in class, we went over to the Yoda Speak generator. Oh, I should put these links online. And we typed in one sentence, now is the time for all good men to come to the aid of whatever. All right, we'll convert that to Yoda Speak. To the aid of, now is the time for all good men to come. Yes. Okay, so that's Yoda Speak. That's taking one group of meaning, translating it into another language, and having the meaning come through. That's changing in syntax. Okay. We could do the same with the Jar Jar Binks program. It's going to come out different, but they'll get the same effect. Scratch will give you the same effect, but we won't have to spend all of our time going through the fine points of exactly precisely getting the syntax correct. And we want to talk about the big ideas in this program. Okay, in addition to scrap and snatch, which are perfectly fine for this class, we will also use sidewalk chalk, construction paper, origami, other things called unplugged assignments that you'll be getting. These unplugged assignments are not fun assignments. They're not make work. They're actually important conceptual projects, and it's very important for computer scientists to be able to step away from the code and think conceptually about the big ideas that are underpinning the design. When I was an engineering manager, we did this a lot. You had to come together as a team and design the software using post-it notes and markers and string, or other things like that, where we forced ourselves to step away from the computer. So please don't skip the unplugged assignments. They really are there to help you learn the big ideas. Okay, come back for the next session.